morning, everyone. My name is Trish Wells, and I'm the project manager for Team B5. Thank you so much for attending our Applied Project Showcase this morning, and we look forward to telling you a little bit about what we've been working on for the last year. Our project is titled Reimagining Puyallup's Economy, and our client is the City of Puyallup. Our client representative is Meredith Neal, Economic Development Manager, and our project sponsor is Steve Kirkley, City Manager. I want to start off by introducing the team. Team B5 is comprised of Bhuvana Kupusamy, Chandler Thompson, Semra Chernit, Tata Kulabali, and myself, Trish Wells. Now for the background. Puyallup has seen a considerable drop in sales tax revenues, the largest source of revenue, because of the COVID-19 pandemic. In early 2020, the city reached out to the school with a proposal because they would like to gain deeper insights into their historical sales tax revenue, identify opportunities for revenue growth, find ways to increase their economic resilience to recessions, and identify resilient business sectors to attract to the city. We used this broad proposal to develop a high-level goal. This goal was to develop a prototype analytical solution that would allow the city to improve their operational processes and customer understanding by deriving insights from historical sales tax data in order to incorporate this knowledge into their plan to build a stronger and more resilient economy. We broke this down into more manageable deliverables, which I'll go over after briefly discussing the analytics architecture. The city provided their historical sales tax revenue in Excel. We then uploaded this data into our Azure SQL database, which is also where we cleaned and transformed the data. We performed our data profiling and discovery in R and Tableau, and we performed data visualization in PrepFlow and Power BI, which was then provided back to the city. Next, we will discuss the 4 different types of analytics. First is descriptive analytics. Descriptive analytics aims to answer the question, what has happened? Common forms of descriptive analytics include dashboards, scorecards, and data warehousing. The outcome of effective descriptive analytics are well-defined business problems and opportunities. This rolls right into diagnostic analytics, which tries to answer the question, why has it happened? Often, diagnostic analytics is bundled with predictive analytics, which tries to answer the question, what is going to happen? Common forms of diagnostic and predictive analytics include data mining, text mining, and forecasting. Finally, we have prescriptive analytics, which tries to answer the question, what should we do? Prescriptive analytics include optimization, simulation, and decision modeling. At the end of prescriptive analytics, you should know the best possible decision and action to take. To the right, in that graph, we can see that the more complex the analysis, the more potential value it has to the business. Let's move on to deliverables. Our first deliverable was creating a sales tax revenue prediction model. The objective here was to quantify relationships between key economic indicators and sales tax revenue using a regression model that can then be used to predict future sales tax revenue. In essence, we wanted to see if there were key economic indicators, such as unemployment or inflation, that could be used to help predict future sales tax revenue. This falls under predictive analytics, and the method was a seasonal REMA model with exogenous variables using RStudio. Our second deliverable was a sales tax revenue dashboard. The objective here was to track historical sales tax revenue trends by industry, or NAICS code, and sector. This falls under descriptive/diagnostic analytics, and we use a report in Power BI. Our third deliverable was a series of demographic dashboards for the city's economic development website, choosepuyallup.com. The objective here is to attract businesses and help them make informed decisions by visualizing key economic and demographic data. This falls under descriptive analytics, and the method was reports in Power BI. Our fourth deliverable was creating a 2020 sales tax revenue dashboard. The objective here was to examine the impact of COVID-19 on sales tax revenue across the city's various business sectors. This falls under descriptive analytics, and it was a report in Power BI. Our fifth deliverable was creating a word cloud and sentiment analysis of a text entry survey. This objective was to obtain actionable insights from the open response survey questions on the city's 2020 Vision Survey. This falls under diagnostic and prescriptive text analytics. We used Azure Cognitive Services Text Analytics API for Power BI. Our final deliverable was creating a Q&A chatbot. Our objective here was to create a Q&A chatbot for the city's website that will answer frequently asked questions and guide users to their appropriate solution. This falls under prescriptive analytics or artificial intelligence. We used Azure Bot Service. Now, we like to take some time to show some of these deliverables in action. We're going to start with our sales tax revenue prediction model. So I've opened up RStudio here, which is where we created our model. I have up a graph of our forecast, and I'm just going to make this bigger so it's a little bit easier to see. Here we see actual sales tax revenues from 2012 to 2019. We then use our model to predict 2019 sales tax revenues, and that's this blue line here. This gray band represents our error band that's built into the model. We overlaid it with actual sales tax revenues, and that's this black line right here. We can see that our model does a fairly good job of predicting sales tax revenues. There is 1 month where it falls outside of our error band. However, that's due to a systemic change in how they collect sales tax revenues. And this can be soaked up using a dummy variable in future iterations of our model. So with this complete, we want to move on to our COVID-19 dashboard. So as a reminder, this dashboard was created to compare 2020 sales tax revenues with 2019 sales tax revenues by sector to see the full impact of COVID-19. Here I have department stores pulled up, and we can see that they were severely impacted by COVID-19 and never quite recovered to their 2019 sales tax revenue levels. And that's confirmed here, where we can see that they ended up finishing 2020 with $250,000 in sales tax revenue, which is about 60% of their 2019 levels. Another type of recovery I want to highlight isn't so much a recovery. However, it's a sector that actually was boosted a little bit by COVID-19, or at least that's the idea, and that's beer, wine, and liquor stores. So we can see here that at first, 2020 sales tax revenues were tracking fairly closely to 2019 levels. However, when COVID really started to get going, we see a big boost here. And they ended up finishing the year with almost $85,000 of sales tax revenues, significantly higher than $68,000 from 2019. So with this dashboard complete, I next want to show off our demographics dashboard. So this dashboard was created with businesses in mind. And the idea is that businesses could come to the Choose Puyallup website and pull up this dashboard and get information about the demographics to see whether or not it makes sense for them to set up shop in Puyallup. So the first dashboard I wanted to show off is the employment dashboard. We can see here that employment is dominated by the retail trade, followed by healthcare and social assistance, and then manufacturing. Here it's also broken out by gender, so we can see that females dominate the healthcare and social assistance sector, while males tend to dominate the construction sector. Next, I wanted to show off the median income dashboard. And this shows that the highest median income by sector would be public administration, followed by, the opposite end of that spectrum. The lowest median income is arts, entertainment, food, and accommodations. Another dashboard I want to show off is commute. So this shows all those that are commuting to Puyallup as a percentage of total commuters. So we can see here that the darkest line is Tacoma, indicating that the majority of commuters to Puyallup are coming from Tacoma. Another dashboard I want to show off is the Redfin data. So this Redfin data shows us that the median price of a house is $525,000, and we can see it by bedroom here, which is mapped against price. Similarly, we can see rent data. We see that the average apartment size in Puyallup is 955 square feet, and the average rent is $1,619. So with this dashboard complete, I want to wrap up with our Q&A chatbot demonstration. And I have our chatbot using an API connected to our Slack channel, but the idea here is that this would be on the Puyallup website, and it's there to answer frequently asked questions. So for example, if I want to ask, how do I start a business? The chatbot responds that you'll need to contact the Washington State Business Licensing Service, and so on. Another question I can ask has to do with COVID-19. So are there travel restrictions? And the chatbot responds that there are currently no travel restrictions in and out of Washington State, etc. And it also provides a link to the CDC here. So that wraps up our demonstrations, and that brings us to our conclusion. For further analysis, we do need to consider that we do have limited data. So from 2012 to 2020, we only had about 90 data points, which isn't a lot when we're doing time series analysis. Second, we do need to add an annual filer dummy variable to help soak up some of that variance that we saw earlier in our demonstration. Our final recommendations to the city are to include the prediction model in the budgeting process, deploy and update the sales tax revenue dashboard, fine-tune and deploy the demographics dashboards, and deploy the chatbot on the City of Puyallup website. Thank you so much for your time today, and we look forward to answering your questions this afternoon in our poster session. Thank you.
Hello, everyone. Thank you for coming to our showcase today. We are Team B6. I am David, along with Trudy, James, Hari, Sharo, and Spoody. Next slide, please. Here is our agenda for today. First, we're going to go over our project overview and what we've been working on all year, which consists of going over architecture tools that we use to perform our analysis. Then we're going to go do our dashboard demo of all the great things we were able to accomplish this year. Next, we will give our recommendation on what we think our client CHI should move forward with based on our analysis. Last, we'll leave some time for some Q&A at the end. And if anyone feels like they want to chime in, they can join us in our breakout room. A little bit about us. We are UW Tacoma Masters of Business Analytics grad students. We've been lucky enough to pair with CHI, now known as Virginia Mason, to help make their business decision using our analytics skills. Our goal for our applied project was to identify key barriers that would increase patient length of stay at their hospitals. We were able to do so using data solutions such as SQL, Power BI, R, RapidMiner, Python, and Streamlit. We were able to produce great visuals and dashboards to show our finding. Shara will go into more detail on how we were able to apply all these tools to bring the visual to life.
Thanks, David. In the last 4 quarters, we have worked on different types of analytics. Let us now have a look at the high level to understand our tools and techniques we used in each phase. Collecting of raw data. All the data is stored in our client's SQL reporting server. We used SQL Server Management Studio for assessing and querying data and converted JSON objects to flat tables to the data once was exported was stored in Excel. The next phase, descriptive analytics, tells you what has happened in the past. We perform bivariate analysis on patient access days against patient demographic, major diagnostic categories, and diagnostic related groups using Power BI. Diagnostic analysis. It helps you understand why something has happened in the past. We determined the barrier-to-barrier correlation using RStudio. Moving on to predictive analytics. It predicts what is the most likely to happen in the future. We implemented cart analysis and created a model using Azure ML Studio with 2-class boosted decision tree with a good prediction accuracy score and identified top significant features that has the most impact on access days. The next phase, being prescriptive analytics, recommends actions you can take to affect those outcomes. We analyze the barriers, descriptions, and other free text using Python and RapidMiner by using text mining techniques. We also created a data dictionary in Python for future analysis and automation. The final one being cognitive analytics. It is a subfield of artificial intelligence using self-learning algorithms through data mining, pattern recognition, and natural language processing. Our final product is an anomaly detection application to predict anomalies in excess number of days. It gives an alert whenever a patient is projected to have a greater than some number of excess days. Once we input the data required, our team built this application using Python and Streamlit. I would now like to hand over to James, who will share the demo with us.
Thanks, Cheryl. All right, so now I'm going to take the concepts we were just discussing and apply them to a live demo of our work. First, I'm going in R for our heat map, which you can see here. This is a series of correlations between the dependent variable and a series of our independent variables. The colors represent the bluer it is, the more positive the correlation, the redder it is, the more negative the correlation. And you can see that there's a few variables that have a slightly positive correlation. Against the dependent variable on the upper edge and left edge, they are a little bit lesser of a positive correlation. If I reduce to just the variables that have the higher correlation to the dependent variable, they range somewhere between 0.21 to 0.3, with 1 being the highest. Next, moving on to the two-class boosted decision tree. We did this work in Microsoft Azure Machine Learning. So here you can see all the pills that represent completing this entire model. First, we start with importing the data. Next, we selected the columns that we thought would be beneficial for this model. Edit metadata. Ultimately, this was making sure our categorical variables were maintained categorical. SMOTE, we had to do this because our binary predictor variable was unbalanced. It was about 15% yeses, 85% nos. So this is synthetic minority oversampling technique. And we wanted to balance the data by creating synthetic observations to go into the smaller category. Next, we split the data into 75% training, 25% testing. This is the two-class boosted decision tree mentioned earlier. And then finally, we can run it all and look at the performance of our model. So there's a lot going on here, but some of the bigger items, we had an 81.9% accuracy. A little bit more importantly for this model is we wanted to really focus on the recall, which was 78.4%. The reason why we wanted to look at this was because that 15% subpopulation, it's a small part of the population, and we really wanted as many of those true positives to be found as possible, even if it meant allowing a few more false negatives to happen. And then finally, the F1 score, which is a balance of the recall and the precision, was fairly high as well at 77.8. So this was a pretty well performing model. And next up, to continue with the live demo, will be Hari.
All right, thank you, James. So, in addition to the two-class decision tree model, we also implemented a card or a classification regression tree to predict the range of access days. Here's a sneak peek of our workflow in Python. We started with importing the required libraries and the dataset, and then there was some pre-processing, and we defined the required features and the label for this analysis. There were some issues with the classes being a bit imbalanced, but we were able to overcome that using oversampling techniques such as SMOT and some hyperparameter tuning. One good aspect of a decision tree is that you can look at it visually and understand how the samples are split into different nodes. In this case, I have used Gini as my impurity criteria because it gave me much better scores than a few other options that I tried. Now, once you have the model, you would want to look at the evaluation metrics to see how good it is at predictions. Again, being a binary imbalanced data set, it's not possible to look at the accuracy alone. So we looked at other measures like recall and then the receiver operating characteristics or simply the AUC. This is nothing but a measure of how good the model can segregate between the different label classes. Then we also plotted a confusion matrix that can tell you the number of correct and incorrect predictions in each of the label classes. Now let's see how we deploy this model into a Python web application that can detect anomalies. So, an anomaly in our case would be a scenario when a patient has exceedingly high number of access days. We can always define on the back end what needs to be considered as an anomaly. In this case, I have set it as 10, which means a patient having more than 10 number of excess days will be considered as an anomaly. Now, once the system detects a scenario like that, it would provide some alert along with the patient summary and the details of the top discharge barriers that are responsible for causing that. We can then maybe take some action to mitigate or curtail the actual length of stay of patients. Here is an example of the applications that is created using Python and Streamlit. So what you see on the left sidebar contains a few of the input features that you can supply to the applications. Here we have a patient with an age of 70. I'm going to change it to maybe 60 for the time being, and then add a barrier, or maybe two barriers, and then click on the submit button. It seems like the model says there is no access days for this patient, and let's try to change that by adding a few more barriers that could be added to the patient. And all I have to do would be click on the submit button again, and it should be able to tell me the prediction. In this case, the patient is found to have high number of access days. You can look at the details by clicking on the check mark, and that should tell you the probability of predictions for each of the classes, followed by the relative feature importance, which is basically the leading factors that were responsible for causing these anomalies. Now, this dashboard or the proof of concept contains a semi-automated data flow. We would recommend building a streaming data source that can provide real-time alerts on the go. Now, I would like to hand it over to Shruti Saxena to go over the recommendations.
Thank you, Hari. Now, I would like to go over the issues, assumptions, concerns, our proposed solution, and recommendations. Now, starting with our challenges, we worked on a limited data set of 560 records from June till November, and it was pulled out from GE Tiles history, where it was stored as a nested JSON objects having a key value pair. We had to perform data transformation in Excel and change numerical data to binary for all the task barriers. It also had similar task codes. For example, C19 or COVID should have been in one category ideally. We faced issues with medical acronyms in task comments, which required extra digging and understanding of the medical terms. As a part of assumptions, we expected a comparatively larger data set, and to perform regression, we have that largest data set of 861 records now. However, two-class classification solved the issue then. Regarding the category, other barriers, it consists of important categories and should have been categorized accordingly. Concerns included the impact of COVID-19 on our overall prediction. Then coming to DRG labels, there are more than 150 unique DRG labels, with several of them having a count of excess days less than 10. So our concern was visualizing all of them. Our predictor variable excess days was also unbalanced, and to rectify that, we used mode pill and oversampling. So finally, we have a proposed solution or recommendation. We suggest other barriers to be excluded until further categorization, or Virginia Mason can opt to use a cross-reference table for all unique task codes, which are team created based on the 861 records we have presently. And also to use a specific list of task codes. We suggest using Python or RapidMiner for task grouping. A fourth suggestion would be using Power BI question and answer, which allows the user to ask a natural language question and get an answer in the form of a visual. Then word cloud can also be used in Power BI to find prominent or prevalent task barrier rather than digging into text. Lastly, we recommend using anomaly detector for predicting anomalies causing the excess days. Now we would like to thank Professor Haluk and whole Center for Business Analytics teams and our clients for Virginia Mason for this wonderful opportunity. And please let us know if you have any question and answers. We will be happy to answer them in our Zoom meeting room.
Hello, everyone. We are MSBA Team B7, working with the Korean Women's Association. And today for this presentation, we have Cody, Hannah, Richard, and myself. So I will talk a little bit about the project background. The Korean Women's Association employs over 1,200 caregivers who need to complete and maintain their training requirements. The KWA requested that our team create a training matrix to assist them in keeping all caregivers in compliance. The KWA currently uses two data sources, the ClearCare and SEIU, and currently there is no process in keeping the data reconciled. Our team was tasked with assessing KWA's infrastructure and providing recommendations to improve their business flow. Their current data flow looks like this. Users at KWA enter caregiver data into ClearCare's web portal. The data gets stored into ClearCare's database, which is stored in their backend SQL database. Developers at ClearCare create SQL queries to run various reports for KWA. Administrators and managers at KWA can then pull the reports out of ClearCare in Excel form. Another data source KWA has access to is their union SEIU data. And ideally, KWA wants to utilize the SEIU data to update their ClearCare database to ensure the most accurate training information for their caregivers. And with that, I'm going to pass it off to Richard.
Thank you, Danielle. Hello, my name is Richard, and I'll be talking to you a little bit about the data that we've been working with. So the data in which we have been working with comes almost exclusively from two different sources. The first of which being ClearCare, which is KWA's database management system, and the second being SEIU, which is an employee union in which we're able to pull reports out of. Now, we did in fact get reports from both of those sources. The data in which we looked at was Excel files, and we use those Excel files to conduct our forms of analysis and the various tools in which we did. The work that we did included a reconciliation between ClearCare and SEIU. That was done just about entirely in Excel. We did bring in some advanced functions in order to assist with the process. So we brought in macros to help us with the cleaning part of it, and we used macros to help it be a repeatable function, whereas we could just change the data. By just change the data, you still get the same outcome. And then pivot tables to help with the visual and layout of the data and to help people use it and read it in an effective manner. We also provided a list of recommendations, which also came in an Excel format. And these included very simple, easy to apply recommendations. So anywhere where there may have been a variance in between the names in both data sources, anywhere where there may have been missing birth dates, a maiden name used instead of a new last name, we found those errors and we provide them with those errors or spots where there could be improvement. Pretty much anything that hindered easy comparability between those two data sources. And the third thing that we also delivered was a dashboard and Tableau. And I'll let Hannah and Cody talk to that a little bit more. The benefits of the work that we have been doing pretty much includes greater comparability between data sources, because at the end of the day, KWA wants to be able to compare ClearCare, what they have in their data source, to SEIU 775, which the union has in their data source. To be able to compare both of those and make sure that both of them are up to date is crucial. Another benefit of what they could be getting out of our work includes uniform record keeping, potentially cleaner data, and more information for management to use in the event of making decisions and getting a better understanding of what the KWA is at in the current moment. And so with that, I'm going to pass things off to Hannah. Thank you.
Thank you, Richard. My name is Hannah, and I will be talking about the predictive analytics we utilized and the overall deliverables. So the next phase of our project was to take a predictive approach to the data, particularly looking at caregiver certifications and how accurately we could predict when these certifications would expire. To do so, we ran various predictive models and identified variables of significance in each. Identifying the variables that were the most impactful models would assist KWA in determining relationships between the certification expirations and different variables in their data, including demographic details, certification types, and internal alert measures. We wanted to identify any demographics that led to higher expiration rates, including age and location, or if there were any specific KWA procedures that aided or hurt in this process, such as offices that may need additional resources, or the amount of time between alerts and the expiration dates. So we utilized RStudio to complete a logistic regression model with 93% accuracy in predicting certification expirations. This model found that certification types were the most significant variable in predicting expirations, meaning the different certification types had different likelihoods of expiration. In Microsoft Azure, we completed a wide range of classification models. Our top 3 models all identified alert date as the most important feature in our model. Alert date is the date set in ClearCare that alerts the caregiver and manager to an expiring certification. So this date is manually entered and ranges from 1 week to 1 year, with most ranging from 2 weeks to 2 months. Our best classification model was the 2-class boosted decision tree with 96% accuracy. Our project deliverables consist of descriptive and predictive dashboards created utilizing Tableau. Cody will be demoing these next. So these dashboards will assist location managers to keep track of their outstanding certifications and any upcoming expiring certifications. This will help KWA's caregivers remain compliant with local and state agencies. The predictive dashboard will assist managers to further analyze the certifications, including the historical data, the most common expiration dates, and a forecast of predicted expirations in coming months. This can allow them to utilize resources better and to focus on those certifications with a past history of being non-compliant. Our next deliverable are custom Excel macros that Richard discussed. One of the major problems we have faced this year was how to reconcile their union data and the data within their own system. So going forward with our Excel macro, they can pull the SEIU data and compare it with the data pulled from ClearCare, find the discrepancies and address these on a monthly basis. They can then update ClearCare with the accurate information, ensuring that these dashboards continue to function properly. That brings us to our final deliverable, our recommendations going forward. First, we recommend KWA update their data input procedures and data cleaning processes. With our Excel macro, we should get them started on addressing these problems, but without making changes to their procedures, the discrepancies may continue. Some of our procedural recommendations are to train all admin staff on the importance of accurate and complete data entry, including which fields hold significance and why, and to come up with an internal document for training purposes to ensure all KWA office locations are entering complete caregiver data in the same way. Our next recommendation is to utilize machine-driven applications to reduce processing time and any human error. These problems can be reduced by changing the format of different fields within ClearCare and having alerts to bring attention to admin. For example, setting the expiration date of all certifications as a required field to save and move on in the data entry screen. An example of an alert could be if a birth date was entered below 18 years old or above 90 years old, as this is an unlikely age group to be working and should require verification. Both of these variables are critical in keeping track of expiring certifications and should be entered accurately. Our last recommendation would be for KWA to update their data infrastructure to allow analytical tools to directly access the data. Currently, we have to pull the data from ClearCare and upload this into Tableau to populate the dashboards. Because this is a manual task, it is time-consuming, leaves room for error, and if not completed accurately, can lead to untimely reports. If Tableau were able to integrate directly with ClearCare, they can run the dashboards at any time and know the data was the most relevant. Cody is now going to demo the different dashboards we've created in Tableau.
Thanks, Hannah. So that brings us to the last phase of our project, which has been focused on packaging up our analysis and utilizing it to provide the KWA with realistic and implementable options on how to improve their business process. You can see this depicted here on the screen, extracting the data from ClearCare, transforming and loading the data, and inputting it into Tableau in order to make more informed business decisions. With the custom data pulls created in ClearCare, we created 2 dashboards in Tableau. The goal of these dashboards was to maximize simplicity while still accurately depicting KWA data through effective visualizations. Our Tableau template allows the user to upload 2 separate ClearCare reports and provides them with provided the columns remain the same, the dashboards will work out of the box with little to no input from the user. Here we can see the first dashboard, which is focused on descriptive statistics. We see the general numbers of active and expiring certifications. Several calculated fields were created earlier, and which allows us to visualize the range of expirations separated by type as well as by location. This dashboard will be extremely useful for the KWA as they look at their current business standing with regards to expiring certifications. Next, we moved on to predictive analytics within Tableau. Tableau has several built-in analytical tools that can be leveraged rather easily with little to no training required by the user. For this dashboard, we focused on 3 of these such tools: trend analysis, forecasting, and clustering. We see the clustering analysis at the top, and Tableau uses a k-means algorithm to group types into like distinct categories. We see with the KWA, the algorithm groups them by type, with one certification being split into 2 distinct groups. We can also see an average number of days expired for the certifications. Next, on the bottom left, we see a trend analysis, where a polynomial trend line was best fitted to the data that clearly fluctuates by month. Here we can see that January, June, and October are months where most certifications become expired. Lastly, a forecasting model was used to predict expiring certifications. We chose to forecast out 90 days. The Tableau forecasting function utilizes exponential smoothing to select the best forecast model out of a list of 8 and provide numerical predictions based off that model. We can see those predictions and the numbers associated on the bottom right. It should also be noted that we created several R plugins for Tableau. This allows us to conduct more powerful generalized linear models or logistical models should they want to expand their analytical capabilities. We also created an auto ARIMA forecasting model through R to provide a more powerful forecasting function. These functions, however, require a lot more user experience in programs like R, as well as a moderate coding ability. Given those requirements, they are left out of the dashboard, but can be implemented at any time should the KWA choose to in the future. Moving back to our PowerPoint, we have delivered our project goals in delivering a comprehensive dashboard, reconciling the data, and providing process improvements. The impacts of these are to drastically reduce time it takes to implement the 2 data sources, as well as data uniformity across ClearCare and the KWA. Mitigation of compliance and data management issues can also free up hundreds of hours of manpower that the KWA can utilize elsewhere, which can lead to an overall comprehensive business improvement for the KWA. With that, our contact information is listed here, and we would love to see you in the Q&A portion next. Thank you.
you.